Okay, let's unpack this. We're doing a deep dive into a concept that is so massive, so counterintuitive. It really forces you to question the very structure of reality. We're talking about parallel universes.
And the broader idea of the multiverse.
Exactly. And the sources you sent over are fantastic. They cover everything from, early quantum mechanics papers to the latest data from cosmological surveys.
Right.
So our mission today is to cut through all the science fiction stuff and give you the real essential nuggets to show you that the multiverse isn't just one big sprawling idea.
It's not. It's actually a collection of distinct and sometimes even incompatible scientific models.
Okay, so when most of us hear parallel universe, we immediately think of that dramatic what-if scenario. The moment you wish you'd taken that other job or said something different, that feeling that every decision you make branches off into a whole different life.
And that's actually the perfect jumping off point, because in physics, that's not too far from one of the main ideas. But the key insight, I think, is that the multiverse isn't a single theory.
It's more of a framework.
It's a framework, exactly, or a classification system. Physicists often separate them into levels to house these completely distinct models, and each one is trying to solve a different fundamental puzzle about the universe.
So we have to constantly ask, is this a prediction based on actual data, or is it more of a necessary consequence of some really complex math?
That's the critical question.
All right, let's jump into those core ideas then. And let's start with the one that feels the most personal and, frankly, the most bizarre.
The many worlds interpretation, MWI.
Right, MWI. This comes straight out of quantum mechanics, the physics of the super, super small. So you know how before you measure an electron, it can be in a superposition, spinning both up and down at the same time.
Right, it exists in a cloud of possibilities.
And the traditional sort of textbook view is that when you measure it, that cloud, the wave function, it just collapses into one single reality.
But MWI says no. It rejects that collapse entirely. Hugh Everett, back in 1957, he argued that the universe doesn't pick one outcome.
It picks all of them.
It accommodates every single possible outcome by splitting. The universe itself branches.
So every time, every single quantum interaction, a photon hitting a screen, a particle decaying.
The universe forks. It's a solution to what physicists call the measurement problem. The insight here is that reality isn't collapsing, it's constantly expanding. It's gaining parallel universes every nanosecond.
So if you're trying to visualize this, you shouldn't be thinking about like stepping into another room. It's more like our reality is just one twig on a tree that's perpetually, infinitely branching out.
That's a perfect analogy. And the cost of this neat solution is an effectively infinite number of parallel realities.
And all the versions of you in these other realities are, I guess, linked. You shared the same history right up until that split second.
Up until that microscopic quantum event, yes, they are as real as you are.
Wow. Okay, that concept alone is staggering. But the second pillar is massive in a completely different way. We're going from the quantum realm up to the largest possible scales.
To the cosmological multiverse.
Which is driven by this idea of eternal inflation.
Right. So this theory is rooted in cosmic inflation, that moment of incredible exponential expansion right after the Big Bang.
An idea which has a lot of evidence supporting it.
A huge amount. And the thinking goes, if space is truly infinite, and if that inflation mechanism never truly stopped everywhere, it just sort of fizzles out in some spots but keeps going in others.
Then what happens?
Then you get the spontaneous formation of these disconnected bubble universes, or pocket universes.
So like, our entire observable universe is just one of those bubbles.
Exactly. Think of it like baking an infinitely large loaf of bread that just keeps rising. And within that eternally inflating dough, these little pockets of stable reality, our universe being one, just form spontaneously.
And the huge difference here from many worlds is that these universes are physically separate. You can't just branch into them.
Correct. They're like separate soap bubbles. And because the space between the bubbles is inflating faster than the speed of light, we are completely cut off. Their physics don't affect us. We're outside their causal horizon.
But this one feels a bit more grounded. It's coming from a really successful cosmological model.
It is, which is why many consider it one of the more empirically motivated types of multiverse.
Okay, so that huge cosmological scale is a sharp contrast to the next idea, which this one requires us to think more mathematically.
And embrace the weirdness of string theory.
The brain multiverse.
Yes.
And this requires a pretty major mental leap. We have to imagine extra dimensions, right? Beyond the three spatial ones we live in.
It does. In this model, our entire universe isn't a bubble. It's a brain short for membrane, a three-dimensional membrane.
Okay, a brain. That jargon can get pretty dense. Can you make that clear?
Sure. Imagine our reality is just a single sheet of paper.
Got it.
The brain multiverse idea says that this sheet of paper exists within a larger, higher dimensional space. We call it the bulk.
So the bulk is like the air above and below the sheet of paper.
Exactly. And the real insight is this. Other complete universes, other parallel brains, could just be other sheets of paper floating right next to ours.
Oh, close.
Maybe just inches away, but separated by that tiny curled up extra dimension. We'd be completely unaware of them unless maybe they interacted through gravity.
And this whole structure is basically a requirement for string theory to work mathematically?
It helps stabilize the extra dimensions the theory needs, yes.
So when we look at those three, the branching of many worlds, the distant bubbles from inflation, and these sort of adjacent sheets of the brain model, I can see why the sources mentioned needing a framework.
Precisely. That's where classification systems like the levels approach come in. They just help us categorize these wildly different ideas. We've got a quantum level multiverse, a cosmological one, and a mathematical one. It's the shortcut to being well informed on this.
That definitely helps ground it. But this, of course, raises the biggest question of all. If any of these exist, can we find them? How do we go from these beautiful theories to the messy search for actual physical evidence?
This is where we separate the astrophysicists from the pure theoreticians. And because the cosmological multiverse is rooted in inflation, it offers, I think, the clearest potential path.
To an actual observation.
Yes. Scientists are actively looking for what they call CMB signatures.
In the cosmic microwave background radiation, the afterglow of the Big Bang.
Right. If one of those bubble universes collided with ours way back in the early universe, it might have left a kind of observable bruise, a distortion in that afterglow radiation.
But isn't the problem that if we do find some weird cold spot in the CMB, there could be other less exotic explanations, like just a huge empty void in space or something?
That is the million-dollar challenge, absolutely. We're not just looking for a random blotch. A bubble collision would, in theory, produce a very specific non-random pattern.
Like a perfect circle or
A
something.
circular anisotropy, yeah. Or a specific type of temperature clustering that just doesn't fit with the expected random variations of our own universe. Finding that would be incredibly strong, though indirect, evidence.
What about other avenues?
Another one is gravitational waves. Some of these exotic cosmological events, maybe a phase transition in the early universe, could generate faint but unique gravitational wave signatures that an instrument like LIGO could potentially pick up.
Okay, but what about many worlds? The one with the constant branching. Is there any conceivable way to test that?
Oh, that is extremely challenging because the branch happens and the new reality is instantly causally disconnected. The only real testable element comes down to manipulating something called decoherence.
Decoherence. Okay, so that's the process that makes the weird quantum world look classical to us. It's why we only experience one continuous reality. But can you break that down a bit more?
Think of decoherence as information leakage. A quantum system is delicate and isolated. When it interacts with its environment, stray photons, heat, air molecules, its quantum information leaks out irreversibly.
And once it leaks, the superposition, that state of being in two places at once, is gone.
It's locked into separate, non-communicating realities. In the many worlds model, decoherence is the mechanism that builds the unbridgeable wall between the branching realities. It ensures the two mu's can never interact or merge again.
We can't see the other branch because that separation is instantaneous.
And irreversible. So any test would involve trying to find tiny, subtle deviations in that process, pushing experiments to a precision where the results only make sense if branching is happening instead of a collapse.
That sounds like it's at the absolute cutting edge of physics.
It is. So if we're weighing the options, the hunt for CMB bruises from inflation is probably the most plausible, empirically driven path right now. The string theory brain stuff, on the other hand, remains pretty abstract.
A beautiful mathematical possibility.
Right. Waiting for a testable prediction or maybe a very, very lucky gravitational wave detection.
So if these other realities exist, I think the most important question shifts from can we see them to what does this mean for me? This gets to the core interest you highlighted in the sources, the personal philosophical side. If reality is constantly branching, or if another you exists in a distant bubble, what does that do to your sense of identity?
And here we have to be really careful to distinguish between the models again. For the cosmological multiverse, the answer is pretty straightforward. The other you is just a physically separate, causally disconnected copy.
A cosmic twin.
An identical clone, really, because of pure random chance in an infinite space, there must be another region out there with the exact same particle configuration as your brain and body.
But their life is entirely separate from mine. My consciousness here has nothing to do with theirs.
Exactly. You can never swap notes. They are, for all intents and purposes, cosmic strangers.
But the many worlds model, that changes the relationship completely. If it's true, how is the you that chose option A philosophically different from the you that chose option B?
They're strangers to each other, but not to the total reality. They were connected literally milliseconds ago. The profound implication is that your identity itself is constantly undergoing fission.
You're not one person making one choice.
You're a continuous process of observation that is always splitting into multiple, equally real versions of yourself.
Which brings us back to something like Schrodinger's cat. If the cat is both alive and dead in separate branches.
Then the you who opens a box is also split into two versions, one who sees a living cat and one who sees a dead one. Your feeling of being you is confined to just one of those branches thanks to those walls built by decoherence.
Okay, so if the total reality includes all of these possibilities, what does that do to decision-making? To free will? If every road I don't take is in fact taken by another version of me in a different branch, what's the meaning of the choice that I experience?
It becomes deeply paradoxical. Some philosophers call it quantum fatalism. In our classical view, free will is about having the agency to choose A over B. But many worlds says both A and B must happen somewhere. The total quantum reality is deterministic. All possibilities are realized.
So my subjective experience is just the feeling of riding along one of those branches.
Exactly. You still feel like you're making a choice because you are only conscious of your single timeline, but the weight of that decision is, in a sense, distributed across the entire quantum system.
So free will becomes less about choosing A instead of B and more about just observing which of the predetermined realities you happen to land in.
That's one way to look at it, yes. And it's a radical perspective that changes everything from how you view regret to how you view responsibility.
How so?
Well, if you face a difficult ethical choice and you choose A and feel immense regret, MWI says there's a version of you who chose B and is perfectly happy.
That fundamentally alters the consequences of your actions.
It does. You're only responsible for the path you subjectively experience, but the total quantum machine realized all outcomes regardless.
It's clear that exploring parallel realities is. It's less about finding a portal to another dimension and more about understanding the fundamental limits and structure of our own.
I think so. The sources really show that the multiverse forces us to question our deepest assumptions about space, time, and identity.
So to really get a handle on this, you have to use critical thinking. You have to constantly ask what kind of idea is being presented.
Is it a robust, empirically motivated model trying to solve a real puzzle in cosmology, like the inflationary multiverse? Or is it a highly abstract metaphysical consequence of mathematics, like the brain multiverse? Both are vital for science, but they require different levels of intellectual scrutiny.
It demands a willingness to accept that the universe might just be vastly, vastly stranger than our everyday experience lets us believe. So what does this all mean for you out there trying to make sense of your next big decision, now armed with the knowledge of quantum branching?
It's a heavy thought.
It is. But think about this as you move forward. If there is a version of you in another branch who is right now living out the consequences of the decision you most regret not making today, does that knowledge, even as just a theoretical possibility, offer you a strange kind of freedom to commit fully to the choices you make in this single subjective moment? Something to mull over until our next deep dive.